Assalamualaikum and hi everyone. My name is Imam Salim Nuzadi from Group 2 and our case study is rice cooker. So for the introduction, rice cooker was been categorized as a mass production because of the quantity was over 100,000 and it's also have selected materials in manufacturing, for example steel and cast iron, and it was been selected based on their thermal conductivity, strength and durability. So next is function of the component product. So rice cooker are household appliance that designed to assist human in cooking rice, which is major source for daily food intake. So in 1975, we've been introduced a traditional rice cooker, and which is firstly found in Japan. So rice was traditionally cooked using heavy cast iron pot, and it also need to heat precisely since it was manually being heated by fires. And then around early 20s, we be introduced electric rice cooker, and it was more easier for human to cook rice and also save time. So this is show that the development of the cooking technology in rice cooking.
Hi everyone, now I'm going to continue our presentation with the detailed specification of the final rice cooker. So when we are selecting materials for the rice cooker, the properties of the material must align with the product's function. So it is important that we analyze all the components that form the final product. So in the rice cooker, the components comprises of four main functional groups, namely external housing, thermal system, control and feedback mechanism, and the auxiliary components. For the external housing, we got three parts, which is the outer body, the outer port, and the lead assembly. The outer body acts as a thermal insulator to keep the exterior cool and houses all the internal electrical wiring. And there is also a port handle located at both sides of the housing for users to carry the rice cooker. Beyond functionality, the outer bodies can also feature decorative design. For instance, glossy or matte finishes provide different aesthetic appeals, and customer can choose either one according to their own preference. Next, the outer port. It is a fixed internal chamber, typically plastic or stainless steel, that holds the heating element. The heating element. It indirectly heats the remover in the port and the water, creating the systems that circulate the steam to cook the rice. And there is also an air gap between the outer body and the outer port, which provides an insulation to minimize the heat loss to the environment. Next, the lead assembly. It contains the inner lead, the steam vent, and the gasket. Normally, it is designed to be removable for cleaning purposes. The steam vents often come with the removable cap that act as an internal pressure regulator to release the excess steam. Thus, it can prevent messy overflow. And not to mention, it requires regular cleaning to prevent clogs. Besides that, the gasket inside the lead assembly is a fluid-grade silicone ring that seals the rice cooker until it is vacuum tight, so the internal pressure and moisture are maintained throughout the cooking process. Next is the thermal systems. So for the thermal system, we got two parts inside, which is the inner cooking pot and the heating plate. The inner cooking pot is usually removable and is the most crucial part of the rice cooker. It transfers heat from the heating element below the cooking pot to the water, and it turns the water into steams when it reaches a certain temperature, and finally the rice is cooked. A good inner cooking pot must have excellent thermal conductivity and have a non-stick interior and easy for cleaning. And these pots fit inside the main heating body, and it can come in various sizes, and it significantly impact the rice textures. Next, the heating plate is the core of the rice cooking. It is embedded with an electric heating coil that converts electrical energy to heat, providing the temperature needed to cook the rice. The heating coil is spring-loaded to ensure constant physical contact with the bottom of the inner port. Next is the control and feedback mechanism. So what controls the whole functions of the rice cooker is a thing called magnetic limiter. It acts as a rice cooker thermostat that regulates the cooking process by sensing the pot heat. It will switch off the heating element and change to keep warm as the temperature rises to the curing point. The curing point is of the rice cooker is the critical temperature at which the magnet temporarily loses its magnetism. When this happens, the magnet will release its hold on the heating plate and causing a spring to flip the switch. The curing point is typically around 103 degrees Celsius. At this point, the cooking of rice is completed. When the temperature drops slightly, the magnet regains its magnetism, and the switch is reset for another heating cycle for another cooking. The last one is the auxiliary components. It's the control box. It contains a series of user interface buttons that is linked to the magnetic limiter, so that users are allowed to control the time and mode of cooking. The touch control panel will come with intuitive graphics that makes the rice cooker easier to operate. Some of it even contains indicator lights that provide visual feedback for the user. Next, we come to the material selection part. In this session, we're going to focus on three main parts, which is the inner cooking pot, the external housing and base, and the heating plate. So for material selection, it is crucial that the material selected has to meet certain requirements that we do during the component analysis. Like certain component has to have good thermal conductivity, and certain components has to have good thermal insulations. Yeah. So for the inner cooking pot, there is a lot of commercially available materials used. Like for example, we got aluminium, we got stainless steels, we got ceramic, we got Teflon. And for our product, our rice cooker, the material that we choose is a multiplied stainless steels. It is a composite that consists of layers of different of metals bonded together. So in this case, this is to improve the conductivity of the plain stainless steels. So the aluminium is featured. It means that the plain stainless steels has a poor thermal conductivity compared to the aluminium, but it has certain advantage that the aluminium do not have. So in this case, the aluminium act as a central core, and we got the inner and outer layer are still stainless steel. So these two layers are stainless steel, and between them we got the aluminium central core. So this modification is to improve the conductivity, the thermal conductivity of the plain stainless steel significantly. And next, we go into the external housing and base. So at here, we suggest two different materials. They have similar properties. One is the acrylonitrile tendinstyrene. So and the other one is polypropylene. So both of them is the thermoplastic. Okay, and there is certain different properties between them. So for the ABS, it has excellent mechanical properties such as durability, rigidity, high heat deflection capability. And what makes it different with the polypropylene is it has paintability. So what does it mean? So it is easier for us to um, design the outer body of the rice cooker. It means that we can have a higher quality surface finish. And for the polypropylene, it is a more affordable one compared to the ABS, and it is known for its chemical resistance and high heat deflection. And it also has the best thermal insulation properties which compared to the ABS. So it is more common for customers that looking for budget and mid-range models, while the ABS is for the customers that are looking for a premium, the premium rice cooker. It has a better looking, and if you are just focused on the functionality and you have lower budget, we would suggest that you use the polypropylene materials. So it depends on our market research, like which is our target users, target customers. And next is the heating plate. So the material that we chose to make this part is the aluminum alloy. It's not that we choose that, but there is not many choices that we have for this part. The important properties that is required for this part is the thermal conductivity to ensure quick heat transfer from the heating element to the cooking surface, while the aluminium satisfies all the criteria, and it has excellent thermal conductivity and high durability. So next we come to the surface specification section. Like what we said just now, the material that we are choosing to make the inner cooking pot is multi-ply stainless steel. It has many advantages that is suitable to use as a material for inner cooking pot, but there is the major disadvantages for this material is that it has a relatively poor non-stick ability. So the rice starches are likely to bond to the tiny pores in the steel as it heats it up. This will make it difficult to clean. And our solution is to apply a coating to the inner surface, while the coating material that bonds well with the multiply stainless steel is ceramic. It has a good non-stick ability. Besides that, ceramic is also a good choice for the consumers who are aware of the production impact of products because ceramic is eco-friendly and is non-toxic, thus it does not cause bad environmental effects. Other than that, the inner surface of the inner cooking pot, we also have the rice measuring level lines so that consumers can cook the perfect rice with the help of these lines since it suggests standard water to rice ratio. So to create a permanent mark of the inner surface that lasts after repeated cooking, laser etching is used. The laser burns the measurement scale into the substrate before or after the cooking process. And the rest of the part is the external aesthetics. For the main body, we suggest a high gloss finish, which is easier to wipe clean from steam, while a fine texture can hide some of the fingerprints on the rice cooker. And for the user interface button, we will use the MoTeC texture for the tactile grade. And this is the technical drawing of our product, the exploded view and the orthographic view here.
Hi everyone, my name is Jia Hong, and now I want to present about the third part of this project, which is the stage of the process. So under this session, we have three small topics, which is the alternative manufacturing process, and the second one is the process selected in each step, and the third one is the project. So let's see about the first one is the alternative manufacturing process. So we know that rice cooker has over 100 years of history. The main component of the rice cooker is the inner pot, outer casing, lid, and so on. So by using different type of manufacturing process, we can get the product with a different mechanical property. So now we will explore the first manufacturing process, which is the deep drawing. So there's another manufacturing process that is similar to the deep drawing, which is the stamping. So what's the difference between stamping and the deep drawing? First, deep drawing used to create a complex and seamless hollow part like a cup, like the figure I attached under the slide. So for stamping, it's cut and form the flatter part quickly. So the main difference between these two manufacturing process is the depth. If we want to fabricate the product with a specific depth or a higher depth, so we use the deep drawing process, like the inner pot of the rice cooker. So first, the lower die of the hydraulic press machine will force the metal sheet, and into the die cavity readily and then stretch the metal sheet into the cup-like shape. So the material that's always used in the deep drawing process is the aluminium, since its property is ductile, and it means that aluminium can stretch and bend without breaking. So this property is due to its crystal structure, which is the face center cubic FCC. So its crystal lattice structure allows it to move off dislocation under stretch, so enabling plastic deformation. Moreover, aluminium doesn't become brittle under a cool condition. So deep drawing process is widely used in industry since it has a lot of benefits. But the first one is deep drawing process is suitable for mass production. So we can produce thousands of identical units in a fast rate, and deep drawing process is automated. Besides, deep drawing process is also a strain hardening process to increase the yield strength of the metal sheet. Next, let's see about the metal spinning process. Metal spinning transforms the flat metal plank into the axially symmetrical round shape inner pot. So during the process, the metal sheet is rotated at a high speed, while a hardened roller will apply a lateral pressure and causing the metal to flow over the mandrel and deform into a desired shape. So metal spinning offers several industrial advantages. So it can improve the mechanical property such as tensile strength, toughness, and hardness of the component. And another important advantage that why the metal spinning will be chosen, because we can reduce the material waste if we use metal spinning manufacturing process. Okay, so next for the third manufacturing process is die casting. Die casting have another manufacturing process which has quite similar process with the die casting is the injection molding. So what is the difference between die casting and injection molding? The main difference is the material used. For die casting, the material used in this process is metal. However, for injection molding, we use plastic. So in inner pot, we use metal, which is aluminium. So that's why we choose die casting. So for die casting, we use high pressure to force the metal liquid into a mold cavity formed by two die. And there's two types of die casting process. One is hot and another is cold. So what's the difference between these two? For hot chamber, it allows the metal direct to melt in the die casting machine. So it reduces the time. On the other side, the cold chamber, we need to melt the metal separately. However, for cold chamber, we can produce a stronger or more durable part. So in next slide, here we show the process of hot chamber and for the cold chamber. So next one is the comparison of the process. So now we have these three alternative process. We need to choose what is the most suitable process for our fabrication of inner pot. So we know that deep drawing is automated process, which means that it is high efficiency for creating a deep and a hollow shape. So it is suitable for fabricate large amount of identical unit. For metal spinning, it has the lowest startup cost, while it requires a very high working skill. For die casting, we can fabricate a very complex geometry. However, the high speed and the pressure will cause the porosity, which means that the air will trap into the product. So will reduce the strength of the product. So within these three processes, we choose deep drawing since it is suitable for mass production and it is high efficiency. Next, let's see about the second small topic, which is the process selected for each step. The first one is fabrication of inner pot. Like I mentioned before, this small topic, deep drawing is the most suitable process for this step. So after the flat metal blank is transformed into the cup-like shape, like an inner pot, so it will send to the metal shaping process. So it will shape the base and the lower corner of the inner pot. After that, it will send to the edge cutting bedding to trim the edge. Lastly, the inner pot will send to the metal pressing for the formation of the watermark scale. Next, we can see here is the second process, which is the metal shaping. And next, we see about the fabrication of the outer casing. Same as the inner pot, deep drawing is used to fabricate the outer casing. So the flat thermoform plastic will transform into the outer casing, the shape of the outer casing. So after that, it will send to the edge cutting bedding to create a neat edge. Next, the bottom and the side of the casing will be holed by using the punch machine. So the other components, such as the control panel, can fit up. The last is the surface finishing. So the outer casing will be sent to the powder coating to apply a layer of durable, decorative, and heat-resistant coating. So other than that, a layer of non-stick material, which is known as Teflon, is sprayed onto the interior surface of the inner pot. And lastly, to ensure the coating sticks on the wall of the pot properly, we need to send the inner pot to a curing furnace. So the high temperature will bake the coating and bond the layer of the coating to the pot streamer. So last one, here's the surface finishing process. We can see that we have a spray gun to spray the coating powder to the inner pot. And next, we see about the step flowchart. So the first one, we have a raw material selection. We choose what material we want for inner pot and outer casing. So the next one is deep drawing. And after that, it will send to a cutting to cut the extra part on the edge of the inner pot or the outer casing. And next, we will send to the shaping. After that, it will go to punching to punch out the hole to fit up the other component. And we have surface finishing to coating. As you can see in the figure, we attach. And after the surface finishing, the product will send to the curing furnace. And after that, it will assembly. We'll screw up all the electronic part and the control panel. And after that, we'll packaging and post to the market. So that's all for my part. Thank you.
Now, let us talk about 4.0 engineering application of GD&T in technical drawing. 4.1 Importance of GD&T in rice cooker application. Firstly, GD&T is important for heat efficiency. The heat is evenly distributed throughout the cooking process by using GD&T application. The second one, cost efficiency. GD&T can reduce the reject rate of final product. The third one, for safety purpose. This can prevent rice from overcook that can cause hot spot. The next one, interchangeability of part. The ease of tooling change can improve the performance of the rice cooker. The last one, clear communication. GD&T act as universal visual language to ensure everyone understanding. So 4.2 key GD&T features. The first one, for the component of heating plate, it has GD&T features of flatness for thermal efficiency and even cooking. For inner pot rim, it has GD&T features of circularity for steam, tight seal, and safety. For the inner wall cooker, it has GD&T features of cylindricity for uniform cooking. For sensor pin, it has GD&T of perpendicularity to reliable outer-off triggering. For heating plate and outer shell, it has parallelism so that the pressure will be distributed equally. For the lid latch, the position GD&T feature is applied to secure locking and user safety. For heating plate and central thermal sensor, it has GD&T feature of concentricity. The center of plate and sensor was perfectly aligned. For heating plate ring and central thermal sensor, it has GD&T features of circular runout. This can combine the circularity and concentricity features. For inner pot outer wall or the induction heating coil cradle, it has GD&T feature of total runout to maintain the energy efficiency. 5.0 type of machine for each process. As you can see from the picture, one is the machine for coating process. The second one is for deep drawing press machine. The third one is hydraulic press machine. And the fourth one is edge cutting machine, high pressure die casting machine, round shape bending machine, and the last one, machining machine.
So next is green manufacturing sustainability. So for the first point is we need to promote supply chain sustainability. So companies can work with supplier and transport partners who focus on sustainability. So this will help to reduce carbon emission and ensure ethical practices. So using eco-friendly transport or planning delivery routes efficiently and cutting packaging waste can make supply chain more sustainable. And for the next point is use sustainable raw material. So this involves using renewable or recycled material instead of limited sources. So in rice cooker manufacturing, this may include using recycled metal, for example, or for the cooker body, and also use eco-friendly coatings for the input. So for the conclusion, this project summarizes the design, materials, manufacturing process used in modern rice cooker. So the use of multi-stainless steel, suitable mass production methods, improve strength, safety, heat distribution, and product consistency, while enhance durability and appearance. So the application of GD&T ensure good contact between the inner pot and the heating plate for better efficiency and safety. In addition, green manufacturing practices highlight the importance of sustainability in producing a reliable and environmentally responsible household appliance. That's all for me. Thank you.